everybody. Hello. Hi. Listen, everybody. I'm Sally Goble, and we need to talk about perfection. I work at Deliveroo. So for those of you, some of you might know Deliveroo. Some of you might have seen some of our riders riding around Amsterdam with big boxes on the back of their bikes, delivering food. So I've worked at Deliveroo for around 4 or 5 months now. And when I told my friends and my mum that I was going to work at Deliveroo, they said, yeah, you're going to be riding a bike and delivering pizzas. No, Mom, I'm not delivering pizzas. I work in the engineering team at Deliveroo. And what does that mean? People have a kind of strange or kind of very kind of narrow idea of what that means. They think they just see a consumer website, people ordering food, and a rider turns up at your door. But it's much, much, much more complicated than that. Essentially, we're a kind of complicated logistics company that manages passing food between our restaurant partners, our riders, and our hungry customers. And that sounds all very well, but just think of all the kind of complicated things that make that happen. We need to have the right number of riders on the road at any given time to meet the needs of the exact number of customers. We need to have those riders arriving at the restaurant, at the right restaurant, at exactly the right time when the food has been created and finished and then sent off to our hungry customers again at the right time in the most efficient way as possible. And there are a lot of logistics and a lot of algorithm and machine learning that goes into that. Many, many complex problems to be solved. That's Deliveroo engineering. So I don't deliver pizzas. We're headquartered in London. We operate in 12 countries worldwide. We're a London-based, UK-based startup, and we've been going for around 5 years. And as I said, we have about 180 engineers in our team. I am the engineering manager of a team called Technical Risk Mitigation Team. That's a team of engineers, software engineers, quality engineers, and QAs. And our job is to kind of mitigate technical risk of our products. So not platform risk, but the risk of our products. So many people think that in the fast-paced world of the startup, that we need to move quickly, and we're busy creating software that can beat our competitors, and there's a kind of a trade-off between shipping quickly and perfection, but that's the kind of thing that we have to live with, not a thing that we would desire. And moving fast is a compromise, or perfection is a compromise to moving fast. But I would say we should go a step beyond compromise and positively embrace the idea of imperfection. We should actively reject perfection in software development, whether we're a startup or, in fact, whether you're a more traditional software company. So the aim of this talk is to persuade you that an obsession with perfect software or perfect software development is holding us down, it's holding us back, it's slowing us down, and it's hampering our ability to develop and deliver our software as quickly as we'd like and our customers require. And what's more, it's not necessary. I don't know about you, but I'm really thirsty. So in order to convince you that we should reject the notion of perfection, I'm going to try and answer 3 questions. I'm going to talk about what I mean by perfect software. I'm going to talk about how we need our software to be perfect, or whether we need our software to be perfect. And I'm going to talk about how Deliveroo works with less perfection. So what is perfect software? I'm going to take you back to the olden days of software development and delivery, back to the year 2000, when the software that you worked with or developed or consumed looked a bit like this. It came in a box, pretty indestructible box, actually. It came in a box that came shipped on disks, installer disks. It came with a whole raft of documentation. And if you wanted to buy some software, you would go to a shop, like an actual physical shop, bricks and mortar. You'd walk in the door, you'd select the software that you wanted, you'd pay for it with actual physical money, and you'd take your software back to your computer, and you'd install it disk after disk after disk. If you were lucky, your software came on a DVD. If you were unlucky, your software would come on a CD. Or if you're particularly unlucky, or if, like me, you're just old, your software would come on a floppy disk. And you'd be home, there you go, installer disk 1, installer disk 2. Your software was a very physical thing. If you wanted to then upgrade your software, you'd have to go through the whole process again. You'd go to the shop, you'd select your updaters, you'd pay with your physical money, you'd take it back to your computer, you'd sit down, you'd do the thing all over again. And probably, if you're trying to update your software, it would update once a year, once every couple of years, once every 6 months if you're lucky. But your software would be updated extremely infrequently. And that software needed to be perfect. It needed to be fully featured. It needed to anticipate the needs of its users and the market and its competitors well in advance, for a year in advance. And that needed to have great documentation. It needed to be bug-free. It basically needed to be future-proofed. And the reason your software needed to be perfect was because if you screwed something up, if you got something wrong, you wouldn't have the chance to update it for at least another year. So it had to be perfect. The long life cycle of delivery dictated the need for perfect software. But meanwhile, while we were building all this perfect software, something else was happening in parallel. The internet was happening. I had one of these. This isn't a photograph of mine. In fact, I had a 14.4 modem. That's a bit depressing. The internet came along. In the year 2000, 30% of the developed world had access to the internet by dial-up modem. By the year 2018, 80% of the developed world have broadband access, going on for 4 billion internet users worldwide. And the internet started undermining the need to physically deliver and develop our software. The mode of delivery changed from physical to electronic, and we started releasing our software or shipping our software more frequently. So we changed from shipping it once every year to maybe once every few months, once every 6 months. You could buy your software in a box, but your update would come as a download from the internet if you were lucky. And then then that changed once every couple of months, once a month, once every 2 weeks. Do you remember that? Great, we can update our software once every 2 weeks, amazing. So then once every few days, once a day, multiple times a day. The internet changed our ability to ship, so now we don't even know when our software is being updated. It just happens in the background. And so we thought, oh my gosh, we can speed up the shipping of our software. We need to speed up our processes. So 2001, Agile Manifesto happened. We started iterating, working more quickly. 2008, continuous integration, continuous delivery, automated testing. We started frantically trying to speed up our processes to keep up with the speed of our shipping. All the while, though, we were still trying to be perfect. We kind of transferred our waterfall processes into these kind of tiny little mini waterfall processes. We were still obsessed by being perfect. But I would argue that we were just speeding up the process, and if perfection was necessary because we needed to keep it necessary because we couldn't ship, then surely shipping more frequently means that we don't need to be perfect. So Henry Ford said, when he talked about the invention of the motor car, he said, if I'd asked the customers what they'd wanted, they'd have just said faster horses. And I kind of think the mindset of speeding up our software delivery is just the same as saying we should have faster horses. And I would say what we need to do is we need to invent the motor car. We need to fundamentally change the way we're doing our software development to kind of keep up with the new mode of shipping our software. And I would say that worrying about perfection is stopping us from delivering as quickly as we can. We need to let go of those old-fashioned notions and move on. Because the long life cycle of delivery dictated the need for perfection. So I'm going to talk now a little bit about what that means to us at Deliveroo and how we've changed our working practices and what working with less perfection really means to us. I'm going to kind of tell a few stories about what it means, and I'm going to talk about our engineering team more broadly, and I'm going to talk about what it means to my team, the technical risk mitigation team. But first, I'm going to talk a bit about our engineering team. We're fostering a culture of ship it and see. So we can ship features fast with absolutely bare minimum engineering work necessary. So rather than building something that's fully formed solution, that's made to last, that's well documented, that's well tested, that's well crafted, we're not going to do that anymore. What we need to do is have a culture of continuous experimentation at a fast pace and embrace the messiness that will inevitably ensue. We need to prove the desire for a feature with the least possible engineering that we can do, and then work for a solution afterwards. So what does that mean in reality? This kind of ship it and see culture. What it really means is it's best when our experiments involve very, very little engineering work up front whatsoever. So I'm going to tell you a story about when we launched Deliveroo Plus. So Deliveroo Plus is a bit like Amazon Prime. It's a subscription service that our users, or our regular users, can sign up to, where they pay a monthly subscription and they get their delivery fee waived. So we had an idea that we wanted to create Deliveroo Plus, but we had no idea whether our users would want it or not. Now, we could have done a whole bunch of research. We could have got focus groups in. We could have done some user research, and we could have kind of come to the conclusion. We could have spent months doing it. We could have been confident that our users wanted it. We could have then kind of created a whole bunch of user stories and built a product. But we didn't want to do that. Instead, we started an experiment. We started a really small experiment. We started an experiment in 3 cities in the UK. What we did was we kind of created a kind of a form, a kind of very basic form, where we said to our users, would you like to have a free trial of Deliveroo Plus that's going to last a month, and in a month's time we'll start charging you if you want to carry on with subscription. We created a form. That's all we did. We took their username, we took the email addresses and user IDs of those users. We kind of stashed them away. And then we launched the service. We wanted to wait and see whether people were going to use it or not. And so we waited and we kind of collected a few user IDs, and we launched the service. So what we did, the only bit of engineering that we did, is we put an if statement around the checkout, the delivery calculation in our checkout process that said, if the users have signed up to this, then just give them free delivery. That's the only piece of engineering we did for this experiment to start with. And so we decided, we ran this experiment for a month, and in that time, we realized we had to build our payment system for subscriptions because we hadn't built anything at all. We gave ourselves a month to do it. We knew that it was going to be a bit of a tight time to do it, but we deliberately chosen 3 cities in the UK as an experiment. We deliberately chosen 3 cities in the UK because we would only be dealing with one currency. We'd only be dealing with one third-party payment provider, so we used Stripe, and we knew that we could integrate that with our system pretty quickly. We knew that we didn't have to deal with multiple languages. So in the 4 weeks between launching a call to people to sign up for the subscription and wanting to take their money from them, we built the system then. We didn't actually build it in 4 weeks. We built it in 6 weeks. But we knew that with this service, that if we said to people, hey guys, you've got 4 weeks free trial, but we're going to extend it for another couple of weeks while we build the back-end payment system, nobody was going to worry too much because they were going to get another 2 weeks for free. So that's what we did. We launched it with a very, very bare minimum of engineering that we possibly could. So the whole system to start with, when we launched it, all it was a little bit of CS work, a form, collection of data, a collection of IDs, and an if statement. And that's how we launched, and that's how we iterated through that product. The next thing we're going to talk about is the way we try and deal with complexity. But I just have to say something to you here. One of the things I love about doing these talks is when you decide that you're trying to find a slide that's appropriate for the thing that you're talking about. So I kind of found these juggling people, and I thought, well, what I really want to do is talk about kind of complexity and when it goes wrong. And so I did a Google search for juggling accidents. Never Google juggling accidents. I saw all sorts of things that I really will never be able to unsee again. Anyway, you can't make an omelette without breaking a few eggs. If you move fast, things get messy, and at some point you have to start tidying up behind you. And this doesn't just go for your engineering and your code. It means everything that you've built and every messy process that you have. We had a restaurant workflow for our restaurants that we'd kind of evolved throughout the time since we kind of started working in Deliveroo. And what happened was our restaurants wanted to kind of put some information on our website that our users would see. And what happened to start with was our restaurants would call our account managers, and they would tell them what changes needed to be made. The account managers would put all that information in a spreadsheet. It was probably an Excel spreadsheet. That would then get converted to a Google spreadsheet. That Google spreadsheet would be given to the developers. The developers would do some engineering work, which would make the changes, which would then go on the front end of our website. That whole process was really long and laborious. And we wanted to try and make that faster. We wanted to make it faster. We wanted to make it more efficient. Now, what you might have done is scoped out a whole way of making that system better from start to finish. But we didn't want to do that. What we wanted to do, and we didn't even know if our restaurant partners wanted to be able to input that data themselves and it appear magically on the website. So what we did was we created, again, a form that our restaurant partners could type in the changes that they want, and we told them that that was then going to appear on the website with no other intervention. But that wasn't what was going to happen. What happened was they typed in a form, it went into the Google spreadsheet, and then it was passed on to the engineers, and the engineers did the back-end the back-end work. But what we wanted to do is we wanted to prove to ourselves that our restaurants wanted to do that work themselves, that they were happy to input the data themselves. We would tidy everything else up ourselves. What that meant, in a way, was that we were making our system more complex and more messy because we had our original system with the restaurants calling the account managers who went to Google's Excel spreadsheet, who went to the Google spreadsheet, and went to the engineers. And then we had a second system that we were trialing, which was the restaurants bypassing the account managers and coming straight to us. We made our system more complex rather than less complex. We made it more messy rather than less messy. And the reason we wanted to do it because we weren't confident that our restaurants would do this. But we wanted to do the experiment anyway. We didn't want to go to the trouble of making a whole system that our restaurants weren't going to like. But we approach reducing complexity in the same way we approach creating new features for our users. We want to do things iteratively. The ship it and see culture has its downfalls. It can be messy. The developer who worked on the restaurant workflow said to me in whispered tones, "I'm ashamed of my code. I have no tests. I work so quickly that the system, I don't want to show it to anybody else." So how do you move so fast? You move so fast with care, I guess. If you don't have tests, you better make sure that you have some monitoring in place so that you can make sure that your system is doing the things that you want to, and you're alerted straight away if it's not. And you need to get to a situation where you don't leave a trail of destruction behind you, that you're speaking all the time, that you're very vocal about the technical debt that is accumulating behind you, that everybody knows that you have to spend an amount of your time reducing your technical debt as you work so quickly. So what does it mean, this imperfect engineering that I'm talking about? It means resisting the temptation to build things up front. It means iterating quickly. It means minimal development work. And it means a culture of continuous improvement and development. The beauty of this approach is that you create something that your users don't want, that you can throw it away quickly and start again because you're not wedded to it. So what does this mean, this imperfection, for the team that I work on? It means embracing and fostering a culture of not wrong long. Because in the world of kind of testing and risk mitigation, perfection comes at a price. Perfection becomes a bottleneck. Rather than huge swathes of automated tests that slow you down, rather than lots of manual testing where bugs are found and edge cases are found and everybody's happy that something's going to be perfect before you send it, we've decided to do away with a large part of our regression testing. We've thrown away automated tests to a great extent, not our unit tests or our integration tests, but our regression tests. We've thrown them away, and we monitor things instead. We ship to production and make sure, with a minimal amount of testing, and make sure that we spot our problems in production if we post them. In order to work in this way, you have to have a large set of technical tools that you can use in order to mitigate risk in this way. So feature flagging, you need to be able to roll back. You need to be able to deploy and release separately. You need to be able to canary release or do phased rollouts. And you need to have lots and lots, of course, of traditional monitoring and alerting, as well as business level monitoring. So what does this mean in reality for the team that I'm working with? I suppose it means incremental releases are a central part of what we do. We have a great team in our rider team that creates apps for our riders. One of the things that they do a lot of is feature flagging everything. And that kind of has business implications, or it's kind of born out of business implications, but it has great engineering benefits as well. So we have riders all over the world, and all of those riders can have different use cases. They're on different models of working. They have different currencies, and we kind of roll out features to different countries in different ways. And this is great, in fact, for engineering as well, for testing as well, because it means that everything that we do is feature flagged. It means that we might turn a feature on in Singapore, but we don't have that feature on in the UK. And that means we can be confident that it means that we can deploy our software with our feature flags on at first, and then turn things on incrementally. So what we do, this is what happens with our rider apps. We deploy our software to one country. We then deploy our software to another country, country after country after country, until we've rolled out the whole of the world. We deploy with all of our feature flags off. And then when we're happy that our features or that our software is stable, we start turning our feature flags on one at a time, country by country by country, for all the countries that are using it, of course, until we have a whole rollout to the whole of our infrastructure. And here's the thing with us. It allows us to change our attitude to our regression testing. So when I first started at Deliveroo, I was kind of hearing about this great phased rollout of our apps, and I thought, well, that's brilliant. But then I realized that we were still doing days and days of manual regression tests before we shipped it all. Now we've stopped doing our regression tests, or we're in the middle of stopping doing our regression testing, and we're just sending out our software with a bare minimal of critical testing of our critical paths before we release it, and we can send it out much more quickly. We use this structured rollout to give us confidence that the software that we're releasing is safe. So the last thing I want to mention is business metrics and how they're a vital sign for spotting problems with your applications. Of course, I said at the start of this section that not wrong, long is the kind of basic tenet of what we do. And that fundamentally relies on you being able to spot your problems in production quicker than your users do. Just recently, we migrated one of our services from an old infrastructure onto a new infrastructure. This was a kind of critical service that touched every single thing in our network of services, and it was almost impossible to test. We put this service on our staging environment. We thought, well, it looks like it's working. And then we started shipping it to production. We'd really not done as much testing on our staging environment as we could. And so we started drip feeding our users to our new production environment, to our new infrastructure, bit by bit by bit. And of course, we had lots of monitoring, the usual monitoring that you would imagine around that. We had, we were monitoring latency, we were doing technical monitoring, we were monitoring our 400s and our 500 and our error codes, we were monitoring our database reads. And that was great, but that nowhere gave us a picture of the whole of the service and how that was working and whether we had any impact on it. And I was like, where is the monitoring that allows us to see that our users are getting the food that they've ordered? We didn't have anything. So our data engineering team started creating a dashboard where we could see in real time the number of orders that we were getting every 5 seconds to all of our users all over the world. And this is one of the kind of core things about this ethos of not wrong long, is being able to spot an issue in production as soon as it arrives and have confidence that that is going to kind of cause you a problem before your users do. And I had this idea of the kind of the cardiac monitor and an analogy with that, which is like business metrics are like your cardiac monitor, aren't they? You know, if you have kind of somebody who's a bit ill, you can send them off. You can send them off to have their lungs tested. You can take their temperature. You can do all sorts of things that will kind of tell you what kind of parts of the system are doing that might give you an indication of the problem. But the one thing that's going to let you know whether your patient is alive or not alive, working or not working, is their kind of cardiac monitor. That's the bottom line, isn't it? And business metrics, I would say, are an essential part of knowing the health of your system. And as a team, we're working much more towards improving our business metrics so we know the health of our system and our users. You need to invest time and energy in defining what your kind of critical business metrics are. And you need to invest time and energy in working out what normal looks like so that you can do some anomaly detection and alert yourself on when something's wrong. So what does imperfect testing or imperfect risk mitigation mean? It means embracing not wrong long. It means resisting the need to test everything all the time. It means letting go of an obsession with edge cases. I mean, just as you wouldn't ship, as there's no point in building software that nobody wants, there's also no point in finding the bugs in the software that nobody's using. So we just test the critical paths and then ship and find out if we've broken something in production. So is this a risky way of working? Well, yes. It's risky if you work in a nuclear power station. It's risky if you work in air traffic control. And also, it's risky if you don't have the ability to ship at will. But other than that, I would say embrace the idea of imperfection. Don't your customers mind that you're experimenting on them? Don't your customers mind that you're kind of not rolling out fully featured products? Don't your customers mind that you're unleashing bugs on them? And don't your stakeholders mind that there might be a problem with the business? Our customers are happy when we release our features more frequently than we would do otherwise. And by our customers, I don't just mean our end users, I mean our riders and our restaurants. And our stakeholders are happy when we can move to market faster than our competitors. So for our customers and our stakeholders, this is a compelling way to work. Everybody wins. At the start, I said that this is the kind of way to work for startups, but I really think that this is the way that everybody should work. It's not just about moving faster. It's about embracing a new way of changing, given the changing nature of shipping of software. So at the start, I said the aim of the talk was to convince you that an obsession with perfect software or perfect software development was slowing us down and holding us back and hampering our ability to ship our software that our customers wanted and our business needs. And I've talked about why we need perfect software, and I've talked about why perfection might be a barrier to success. Perfection should never be the starting point. It should always be something to aim towards. More broadly, we need to adapt the way we work to take account of the new way of shipping, but we need to remember that we're not pursuing perfection, and we should have no fear of it because we'll never reach it. Thank you.